According to the National Electrical Code, there are bonding requirements for aluminum balusters located within 5 feet of a spa or swimming pool. The National Electrical Code requires that metal components within 5 feet of a spa or swimming pool must be bonded together. This is to provide a continuous electrical path to ground. This includes items such as balusters, handrails, and other metal parts of the deck. The bonding requirements are as follows: all metal components within 5 feet of the spa must be bonded together with a copper bonding conductor. The bonding conductor must be at least 6 American wire gauge in size. The bonding conductor must be connected to a metal ground rod that is driven into the ground near the spa. Here is a procedure that you should follow. Firstly, connect the aluminum balusters to each other. Use a copper bonding conductor to connect each baluster to the next one. The bonding conductor should be crimped or soldered to the balusters. Secondly, connect the balusters to the railing. Connect the bonding conductor from the last baluster to the metal railing. Thirdly, connect the railing to a ground rod. Drive a metal ground rod into the ground near the spa. Connect the bonding conductor from the railing to the ground rod. Note that the ground rod must be at least 5 feet long and must be buried at least 2 feet deep in the ground. By following these bonding requirements, you can ensure that the aluminum balusters are properly grounded and do not pose a safety hazard. Bonding is a critical safety measure designed to minimize the risk of electrical shock in and around spas and swimming pools. It works by creating a low impedance path for electrical currents, ensuring that all metallic components in the vicinity are at the same electrical potential. This equipotential bonding significantly reduces the potential difference between conductive surfaces, thereby decreasing the likelihood of dangerous current flow through a person who might come into contact with 2 different metal parts. The primary goal of bonding is to protect individuals from electrical shock hazards. In the event of a fault, such as a short circuit, the bonding system provides a path for the fault current to quickly return to the source, tripping the circuit breaker or ground fault circuit interrupter, also known as a GFCI, and de-energizing the circuit. This rapid response minimizes the duration of the electrical exposure, greatly reducing the risk of serious injury or death. The specific requirements for bonding are detailed in Article 680 of the National Electrical Code. This section provides comprehensive guidelines for the installation and bonding of electrical equipment in and around swimming pools, spas, hot tubs, and other similar installations. Article 680 outlines which metal parts must be bonded, the size and type of bonding conductors required, and the methods for making proper connections. Compliance with Article 680 is essential for ensuring the safety of these installations. One key aspect of bonding is the use of a continuous unbroken conductor to connect all metallic components. This conductor, typically made of copper, must be of adequate size to safely carry any fault current that might occur. The connections must be mechanically strong and electrically conductive to ensure a reliable, low-resistance path. Improper or loose connections can compromise the effectiveness of the bonding system and increase the risk of electrical shock. Common metal parts that require bonding include metal fences, ladders, handrails, diving board supports, and underwater lighting fixtures. Any metal component within a specified distance of the pool or spa, typically 5 feet horizontally and 12 feet vertically, must be bonded. This requirement is intended to create an equipotential zone around the pool or spa, minimizing the potential for voltage differences between conductive surfaces. The bonding conductor must be connected to a grounding electrode system, which typically consists of 1 or more ground rods driven into the earth. The grounding electrode system provides a path for fault currents to dissipate into the ground, further reducing the risk of electrical shock. The ground rods must be installed in accordance with the National Electrical Code requirements, ensuring proper depth and spacing. It is important to note that bonding is not the same as grounding. While both bonding and grounding are essential for electrical safety, they serve different purposes. Grounding provides a path for fault currents to return to the source, while bonding ensures that all metallic components are at the same electrical potential. Both bonding and grounding work together to protect individuals from electrical shock hazards. When installing a bonding system, it is crucial to follow the manufacturer's instructions and the requirements of the National Electrical Code. A qualified electrician should perform the installation to ensure that all connections are made properly and that the system is functioning correctly. The electrician should also inspect the existing electrical system to identify any potential hazards and make recommendations for improvements. Regular inspections and maintenance are essential for ensuring the continued effectiveness of the bonding system. Connections should be checked periodically for corrosion or looseness, and any damaged or deteriorated components should be replaced immediately. The ground rod should also be inspected to ensure that they are still properly driven into the earth and that the connections are secure. In addition to bonding, ground fault circuit interrupters, also known as GFCIs, are another important safety device for spas and swimming pools. GFCIs are designed to detect even small amounts of current leakage and quickly interrupt the circuit, preventing electrical shock. GFCIs should be installed in all circuits that supply power to equipment near the pool or spa, including pumps, heaters, and lighting fixtures. The National Electrical Code requires the use of GFCIs in these locations to provide an extra layer of protection against electrical shock hazards. When selecting a GFCI, it is important to choose a model that is specifically designed for use in wet locations. These GFCIs are typically enclosed in a waterproof housing to protect them from moisture and corrosion. The GFCI should also be tested regularly to ensure that it is functioning correctly. A qualified electrician can perform these tests and make any necessary repairs or replacements. Another important safety measure is to maintain a safe distance from overhead power lines when using or working near a spa or swimming pool. Power lines can pose a serious electrocution hazard if they come into contact with water or conductive object. The National Electrical Code requires that a minimum clearance distance be maintained between overhead power lines and swimming pools or spas. This clearance distance varies depending on the voltage of the power lines. It is important to be aware of the location of overhead power lines and to maintain a safe distance at all times. In addition to these technical measures, there are also several common sense precautions that can help prevent electrical shock hazards in and around spas and swimming pools. Never use electrical appliances or devices near the water, and always keep electrical cords and equipment away from the pool or spa. Do not allow anyone to swim or use the spa during a thunderstorm, as lightning can pose a serious electrocution hazard. If you are unsure about the safety of an electrical installation, consult with a qualified electrician. They can inspect the system and make recommendations for improvement. By following these safety guidelines, you can help prevent electrical shock hazards and ensure that your spa or swimming pool is a safe and enjoyable place to relax and have fun. Bonding jumpers are an essential part of the bonding system, providing a reliable electrical connection between different metal components. These jumpers are typically made of copper and are sized according to the requirements of the National Electrical Code. The bonding jumpers should be installed in a way that minimizes the length of the conductor and provides a direct path for fault currents. When installing bonding jumpers, it is important to ensure that the connections are clean and tight. Corrosion can build up over time, compromising the electrical conductivity of the connection. To prevent corrosion, the connection should be treated with an anti-corrosion compound. The bonding jumpers should also be protected from physical damage, such as being crushed or cut. The National Electrical Code provides specific requirements for the size and type of bonding jumpers that must be used in different applications. It is important to consult the code to ensure that you are using the correct jumpers for your installation. The bonding jumpers should be installed by a qualified electrician who is familiar with the requirements of the National Electrical Code. In addition to bonding jumpers, other types of bonding connectors may be used to connect metal components. These connectors are typically made of copper or bronze and are designed to provide a reliable electrical connection. The connectors should be sized according to the requirements of the National Electrical Code and should be installed in accordance with the manufacturer's instructions. When selecting bonding connectors, it is important to choose models that are specifically designed for use in wet locations. These connectors are typically enclosed in a waterproof housing to protect them from moisture and corrosion. The bonding connectors should also be inspected regularly to ensure that they are in good condition and that the connections are tight. Another important aspect of bonding is the use of a bonding grid. A bonding grid is a network of interconnected conductors that are buried in the ground around the pool or spa. The bonding grid provides a low impedance path for fault currents, helping to equalize the electrical potential in the area. The bonding grid should be installed in accordance with the requirements of the National Electrical Code. The conductors should be buried at a sufficient depth and should be spaced according to the code requirement. The bonding grid should be connected to the grounding electrode system, providing a path for fault currents to dissipate into the ground. The bonding grid is an important component of the overall bonding system and helps to ensure the safety of the installation. When installing a bonding grid, it is important to use materials that are resistant to corrosion. Copper is a commonly used material for bonding grids because it is a good conductor of electricity and is resistant to corrosion. However, other materials, such as stainless steel, may also be used. The materials should be selected based on the specific environmental conditions and the requirements of the National Electrical Code. The bonding grid should be inspected regularly to ensure that it is in good condition and that the connections are secure. In addition to the bonding grid, other types of grounding electrodes may be used to provide a path for fault currents to dissipate into the ground. These grounding electrodes may include ground rods, ground plates, or concrete encased electrodes. The grounding electrode should be installed in accordance with the requirements of the National Electrical Code. The number and type of grounding electrodes required will depend on the size and type of installation. The grounding electrode should be connected to the bonding system, providing a path for fault currents to return to the source. The grounding electrode should be inspected regularly to ensure that they are in good condition and that the connections are secure. It is important to note that the bonding and grounding requirements for spas and swimming pools can be complex and may vary depending on the local codes and regulations. It is always best to consult with a qualified electrician to ensure that your installation is in compliance with all applicable requirements. A qualified electrician can also inspect your existing electrical system and make recommendations for improvements. By following these guidelines, you can help ensure that your spa or swimming pool is a safe and enjoyable place to relax and have fun. The correct size for the copper bonding conductor is crucial for safety. Using an undersized conductor can lead to insufficient fault current capacity, potentially causing overheating and failure of the bonding system. This, in turn, increases the risk of electrical shock. Conversely, using an oversized conductor is generally acceptable, although it may be more costly and not necessary for the system's performance. The National Electrical Code specifies the minimum size requirements for bonding conductors based on the ampacity of the circuit to which they are connected. A qualified electrician should determine the appropriate size for the bonding conductor based on the specific installation. The type of copper bonding conductor is also important. Typically, an insulated copper conductor is recommended to protect from corrosion and physical damage. The insulation should be suitable for wet locations and resistant to chemicals that may be present in the spa or pool environment. The insulation also helps prevent accidental contact with other metal parts, which could compromise the bonding system. The routing of the bonding conductor should be carefully planned to ensure a direct and continuous path between all bonded components. Avoid sharp bends or kinks in the conductor, as these can increase resistance and reduce its effectiveness. The conductor should be securely fastened to the metal parts using appropriate bonding connectors. The connections should be clean, tight, and protected from corrosion. Proper installation of the bonding conductor is essential for ensuring the safety and effectiveness of the bonding system. The location of the ground rod is another critical factor. The ground rod should be driven into the ground as close as possible to the spa or pool, typically within 5 feet. This minimizes the length of the bonding conductor and reduces impedance. The ground rod should be driven deep enough into the ground to ensure good contact with the earth. The National Electrical Code specifies the minimum depth requirements for ground rods based on soil conditions. The ground rod should be made of a corrosion-resistant material, such as copper or stainless steel. The connection between the bonding conductor and the ground rod should be secure and protected from corrosion. A ground clamp is typically used to make this connection. The ground clamp should be made of a material that is compatible with both the bonding conductor and the ground rod. The connection should be tightened properly to ensure a low resistance path. Regular inspection and testing of the bonding system are essential for ensuring its continued effectiveness. The connection should be checked periodically for corrosion or looseness. The ground rod should also be inspected to ensure that it is still properly driven into the earth and that the connections are secure. A qualified electrician can perform these inspections and tests and make any necessary repairs or replacements. Neglecting the bonding requirements can have serious consequences. Failure to properly bond metal parts near a spot or pool can create a dangerous electrical shock hazard. In the event of a fault, the unbonded metal parts can become energized, posing a risk of electrocution to anyone who comes into contact with them. The bonding system is designed to prevent this from happening by providing a low impedance path for fault currents to return to the source, tripping the circuit breaker or GFCI. Compliance with the bonding requirements is not only essential for safety but also required by law. The National Electrical Code is widely adopted by state and local jurisdictions, and failure to comply with the code can result in fines or other penalties. It is important to consult with a qualified electrician to ensure that your installation is in compliance with all applicable requirements. A qualified electrician can also provide valuable advice and guidance on how to properly bond your spot or pool and ensure the safety of your family and friends. In addition to the technical aspects of bonding, it is also important to educate yourself and others about the dangers of electricity near water. Never use electrical appliances or devices near the water, and always keep electrical cords and equipment away from the pool or spa. Do not allow anyone to swim or use the spa during a thunderstorm, as lightning can pose a serious electrocution hazard. If you are unsure about the safety of an electrical installation, consult with a qualified electrician. By following these safety guidelines, you can help prevent electrical shock hazards and ensure that your spa or swimming pool is a safe and enjoyable place to relax and have fun. Remember, electricity and water can be a dangerous combination. It is important to take the necessary precautions to protect yourself and others from electrical shock hazards. Bonding is an essential safety measure that can help prevent these hazards. By following the requirements of the National Electrical Code and consulting with a qualified electrician, you can ensure that your spa or swimming pool is properly bonded and that you and your family can enjoy it safely.